Welcome, everyone, to the April 2025 Carbon Leadership Forum of Boston Northeast Reuse Group meeting. Thank you all for coming on this beautiful, at least outdoor Friday. Today, we have a presentation by some people from MIT talking about structural steel reuse, looking at some precedent projects, some research, and what they're finding in their position. So we'll go right into Olivia. Anything before we go into the presentations?
I'm just very excited to see this. So
there we go. So Lili and Juliana, we'll open it up to you.
Hi. Thank you, Olivia and Michael, for having us. It's nice to meet everyone. I'll share my screen.
Thanks so much, everyone. We can just go ahead and maybe introduce ourselves first. Lili, do you want to start?
Yeah, I'm a current master's student at MIT in the building technology department, working on reuse steel along with Juliana.
And I'm a PhD candidate in building technology at MIT, also working on scaling the reuse of structural steel in buildings. So happy to share our work today.
Is it visible? Great.
Yep, all good.
All right. Well, kind of just introduced ourselves already, but broadly, we're part of building technology, which looks at a bunch of different things, but our group is really focused on steel. And we're excited to kind of share with you today what we're working on, but also the state of steel reuse generally. I'd like to open actually with a quick case study. You're probably familiar with this building on Mass Ave. It's the Metropolitan Warehouse. It was built in 1894. And it's this historic masonry building that's currently being renovated to be MIT's new School of Architecture and Planning. And in the process of that renovation, a bunch of masonry was removed, but also a bunch of steel beams. And so our group was actually able to gain access to some of those beams and tested them and found that this 100-year-old steel, which ranged from 1894 to 1936, has capacity that's comparable to A36 steel that's produced today, and in some cases exceeded it, which is just really incredible and raises a bunch of questions. One, how do we actually gain access to the immense amounts of steel that are coming out of demolition processes across the country right now, if it is, if the capacity is just so usable? And second of all, what are the carbon and cost implications of that? And I'll pass it on to Juliana.
Awesome. Thanks, Lili. So I'll just let you know when to click next, because I think you're in Drive right now. So really, to understand the benefits of steel reuse, I think for me, it's best to start at the end, which is the end of a building's lifetime, a steel building's lifetime. And I know there's a bit of an interdisciplinary background here, so forgive me if this is information some of you already know. So what happens to a steel building at the end of life? Typically, it's scrapped. And next. And steel is also scrapped elsewhere in the supply chain. So this image is actually taken from a steel fabricator facility that I have collaborated with that has a stockpile of non-dedicated inventory. And the steel, also called surplus steel, sits in fabricator yards and is either from canceled projects or over orders. And what often happens next is that it can't be certified if it sits in a fabricator's yard for a certain amount of time. And so what will happen is that it's often scrapped. So every piece of steel that you see in this yard was scrapped instead of being used on a new project because it sat in the yard for too long and could no longer be certified, despite never being used on an actual project. Next. So after it's scrapped, steel travels to a steel recycler and is cut up and portioned off into different bushels and separated and sorted. Next. And travels all around the world to be melted down and reformed to create new steel sections and other steel products through two primary process types. So the two primary process types are an electric arc furnace, and a blast furnace or basic oxygen furnace. And of the two here in gray, you see as blast furnace, which is the more carbon intensive option of the two. And the electric arc furnace is here in blue, which is what enables steel recycling. And you have the primary input of an electric arc furnace is scrap steel versus the primary input of a blast furnace is typically pig iron or a raw material. But both processes have both scrap and raw pig iron inputs. And so while it's incredible that the steel supply chain operates in this way and the steel recycling operates in this large of a capacity in this global supply chain, the melting of this steel is not without impacts. And currently today, steel recycling is our best practice. That being said, a lot of, as you can see in this graph, a significant portion of steel production is not actually produced through the more sustainable option, which is the electric arc furnace. And electric arc furnaces rely heavily, their sustainability relies heavily on the decarbonization of the electric grid as well. And so while our electric grids are decarbonizing, focusing on reuse as a sustainability option for steel structures is also a beneficial alternative in addition to the existing steel recycling supply chain. So, as I said, this best practice is not without impacts. So, I just want to take you through some of what those impacts are. So, forgive me if you are a life cycle practitioner that's on the call, but anyone here who has done life cycle analysis knows that a typical LCA method for building follows 4 modules: the product stage, construction stage, use stage, and end of life stage. And the second you add an additional life cycle, next slide, it becomes infinitely more complex. Next, Lili. Oh, right, sorry. Sorry, could you go back once? Thanks. So it becomes infinitely more complicated when a second lifetime is introduced. And this is because not only because the lifetime doubles, but also there's lots of allocation considerations of how we account for what emissions should be attributed to which lifetime. And what this has led to, and how these impacts are typically measured are through something called an embodied carbon coefficient, which are often used often in the unit of kilograms of CO2 equivalent per kilogram of steel and are used to represent embodied emissions. And these ECC values are often produced through environmental product declarations. Next. And of these modules, EPDs typically track the raw material supply, transport, and manufacturing of materials. So just what we would call the product stage, which is A1 through A3. Now, because of what I mentioned about multiple lifetimes where reuse is involved, what we see as a result of when we calculate an embodied carbon coefficient for reused steel, next, results have varied widely for reused steel, both across literature and across industry. So here in green, you have a collection of all the reused steel embodied carbon coefficients that exist, including existing EPDs, but also including various research studies. And in blue, you see the existing ECC values for recycling steel. And what you see is a total consensus, a pretty common consensus across the environmental product declarations for recycled steel EPDs, but there's lots of variation amongst the results of reused steel ECCs. And the reason that this variability is relevant is because if we are arguing for reused steel, we need to understand what the potential benefit of reusing steel is and what the potential impact benefit is. And so we saw this issue early on in our work. And actually, when we started this work, there was no existing EPD for reused steel. And so this is really an emerging field. And there's been EPDs come out really in the last year or two on the subject. And so what we sought to do is to produce an embodied carbon coefficient for reusing structural steel. Next. And in order to carry this out, what we really wanted is conduct a really bottom-up analysis where we had very transparent calculations based on a certain number of processes and a certain number of transport distances to demonstrate the emissions associated with reused steel. And so how we did this was that we obtained 9 real building projects from the Steel Solutions Center at the American Institute for Steel Construction, depicted here, and took out several heavy section beam examples and categorized them by various element characteristics. Next, Lily. And from there, we determined an estimated deconstruction and refurbishment processes for reused steel elements, including hoisting, cutting, and grinding, along with other transport and fabrication impacts. And we're able to calculate across a number of transport distances a wide range of embodied carbon coefficients for reused steel versus recycled steel, and compare them to produce a median embodied carbon coefficient for reused steel of 0.26 kilograms of CO2 equivalent per kilogram of steel compared to 1.22 kilogram of CO2 per kilogram of steel for recycled steel. And we also wanted to assess next the variability of different factors on this embodied carbon coefficient, including transport, which varied widely and had significant impact on overall reuse carbon values, had a more significant impact on overall reuse values than overall recycled values. And this has to do with the fact that for reused steel transport distances, because the overall ECCs were much lower than recycled steel, transport distances had a higher influence on the overall embodied carbon coefficient. Next.
When you're talking about transport distances on the recycled steel, you're talking about like the source of where it came from to wherever it's being manufactured.
Yeah, I guess I'm talking about the distance from where it's being manufactured to where it's being fabricated. Yeah. Yep. So what you're bringing up is this exact point that comes up when we add two life cycles together, which is where does the end of life impact start? Where does the primary impact start? And what you mentioned is a very contentious question in literature, which is where do we account for the recycling impacts? So I'm happy to elaborate on that after or offline. Because it's a more intensive question than we have time for today. But also can revisit at the end. And then finally, we also looked at variability by element. And one thing that we found is that different element types indicated a number of element characteristics could influence carbon emission impacts. And it indicated that these element characteristics such as depth, surface area, and height of an element could influence the overall carbon emission impacts of reused steel elements in particular. But this discrepancy overall is caused by the use of the unit of kilograms of carbon by kilogram of steel, which is evidenced by the lightest element here, the W8/10 section, having the highest embodied carbon coefficient. And the reason that this happened is because we wanted to examine reuse impacts using a unit that would not, the reason that this happened is that we were evaluating element by element processes that were per unit area, for example, but wanted to be able to compare it by these embodied carbon coefficients, which are typically in a weight unit. And so that is why we saw such discrepancies there. So in our work since this project, we've expanded a lot on interrogating this unit, this embodied carbon coefficient unit, to really be able to have like a very apples to apples comparison with recycled steel values. And then finally, before I pass it off to Lily for the rest of the day, just the kind of takeaways from our initial forays into this is that we really found carbon equivalent impacts of reused steel structures is really highly variable based on building project and element characteristics, but we were able to produce this kind of median comparison example both across all literature and industry values and the values that we produced in our bottom-up analysis. And overall, across all of these project examples, we saw a 60 to 83% reduction in greenhouse gas emissions, estimated from reusing steel instead of recycling steel, depending, of course, on the element and project. And all of this, all of the scoping of this project that I just shared was recently published in a paper, which we can share at the end if you're curious, with lots of where we got the data and more specifics. But for now, I'll pass it back to Lili.
Thanks, Juliana. And so as Juliana's work shows, just the carbon implications of reuse are huge. And so then I guess the question is, what are the barriers? Why aren't we doing this? And there are a number of challenges which broadly can be broken down into 4 categories. The first has to do with design. Buildings aren't designed for deconstruction. Next has to do with process. We don't have, as Juliana mentioned, we don't have a certification, and there's a growing regulatory environment. Next is workforce, both on the deconstruction side, but also on the design and engineering side. And finally, marketplaces. And so in the next few slides, I'll share the work that's happening in each of these categories, which is growing and exciting, and also resources that practitioners can access now to work with reused steel in our current context. Starting with design, steel luckily lends itself to disassembly, and there are a bunch of great resources out there, including Public Architecture's Design for Reuse primer, and also a lot of academic literature. And again, all of these resources are linked in the slide deck, which we'd be happy to share after this presentation. Moving on to process. Again, there is no certification in the US, but there are certifications for reused steel in the UK and the Netherlands and Switzerland, which means that steel that's removed from a building can be assessed and marked and resold, just as new steel can, which is really great for designers who just want to have confidence in this material. In the US, we have project-specific specifications, and so there are a number of case studies of engineers and architects who have written specifications about using reused steel. Walter P. Moore did a great one for a project in Austin, Texas, and our group is actually working with AISC to develop a US-based certification, which is really exciting. And as Juliana spoke about, there is no EPD yet in the US context. There are EPDs in the UK and in other parts of Europe. But linked here is Juliana's paper, which is really just laying the groundwork for understanding the carbon associated with reuse in the US, and hopefully with industry collaboration will lead to an EPD very soon. Moving on to workforce, in addition to deconstruction and demolition workforce development, designers and engineers, there are a lot of skills that have to do with reuse that might differ slightly than new steel, and so resources like the Disrupt Toolkit, which comes out of the UK but is definitely applicable to the US context, are super helpful. They include technical aspects, cost and procurement, training, and case studies. And then iStructE's report also has guidance for a number of different actors along the steel supply chain. Working groups and case studies are also central to this. Since it's still a growing field in the US, really learning from precedent projects is huge. And so Circular Steel is a UK-based group, which is doing great work and might be coming to the US soon. And the SEI also has a great case study repository.
And I might just quickly jump in here that there is a very nascent workforce development program on material reuse that we're trying to organize for in Boston right now. If you're interested in being involved, this is more on the trades side, please reach out. I know, Michael, we maybe have discussed this before in previous meetings when we've last met, but if anyone is interested in possibilities around Boston and workforce development and material reuse, please follow up with us.
Yeah, thanks. For sure. And finally, kind of coming full circle to marketplace. As you know, there is no centralized marketplace for salvage steel in the US, which makes it challenging for a lot of designers. But that doesn't mean that reuse doesn't happen. And so wrapping up with the current challenges, I'd like to move into kind of another branch of research that our group is doing on informal networks of exchange and how reuse is happening right now. And as I mentioned, that depends a lot on social networks and informal marketplaces. And So one way in which that happens is just through direct project matching. Demolition site, the steel goes directly to a construction site, and that necessitates communication between contractors, designers, and owners, but also timeline alignment and flexibility. And this is how a lot of the reuse projects we see today are happening, and it's really enabled, especially when the owner is the same for both demolition and construction. On the other side, you just have word of mouth. And as Juliana alluded to, there is scrap steel at many, many different points in the supply chain, from contractors to fabricators. And so people just talking to each other and finding out who has what leads to reuse in a lot of cases. But there are also online informal marketplaces like Facebook Marketplace, Craigslist, eBay, and you can actually get an astonishing amount of steel there. And so building off of this last point, our current project is looking into kind of mapping that informal marketplace and using it to determine supply, demand, and cost of reused steel in the US right now. And so based on an analysis of 135 postings, as well as interviews with demolition contractors and salvage resellers, kind of getting cost estimates for the salvage steel that's available and finding that it varies based on section type and also condition. Broadly, reused steel comes out to about 70 cents per pound, and you get lower prices for heavier sections and for larger quantities, likely because of transport efficiency. And so moving forward, the work that still remains to be done both on the research side, but also in the industry side, has to do with mapping these steel flows and identifying more cases of reuse to show that it's possible. Collaborating with industry and organizations like AASC to build this supply chain and also a steel certification and design guide. And finally, kind of feeding the working groups and knowledge networks that already exist. There are also some great case studies. I'd like to share the Boulder Community Hospital was deconstructed in 2023, and 500 steel members were removed and stockpiled for future use, which diverted about 94% of the material from landfill. And you can see that steel members are being used across Boulder, including in this firehouse in the bottom right. And steel is actually also being reused in bridges. And so in Muskingum County, they've built over 18 short span bridges using reused steel. And it happened through a collaboration with the state, in which when the state deconstructs a bridge, they offered the steel to municipalities at no cost. The steel would otherwise be scrapped. And even though the steel is maybe corroded at the ends, the beams are so large, these are for state level highway bridges, that that's more than enough capacity and span for smaller municipal bridges. And this is a windfall for municipalities, which have tight budgets, because it saves them up to $51,000 in material cost per bridge, which points to the fact that steel reuse also is not just great for carbon, but for cost as well. So finally, where is salvage steel now? It's again really through relationships with contractors and architects and matching between demolition and construction projects, but also relationships with contractors and suppliers to kind of access the surplus that's in other parts of the supply chain. And finally, it can be found on online marketplaces. And all of these strategies to accessing salvage steel before there's kind of a more robust centralized marketplace in the US ask questions about the design process and the order of design first and then procurement. And is there a way to kind of switch it around so that we're designing around members that we already have? And so lots of open questions for practitioners there. And thank you, and would like to say that we would love to hear from you. Juliana and I are always looking for questions from industry and collaboration, and wanted to also open a question to the group for what would it take to integrate reused steel into your projects.
Awesome. Well, thank you so much for that presentation, Lili and Juliana. One question I have before I'll open up to the group. We've heard before from group members in the industry, when looking at kind of reusing structural steel, there's a lot of questions on is it up to snuff? Is it going to have the characteristics that new steel would have before engineers can kind of put their stamp on it? You had mentioned earlier that, well, not in the US, there's other places, you had mentioned the UK and Switzerland, that kind of almost recertify something like that. And given that you went to the warehouse building near MIT and did your own tests, is is it a testing process that is looking to be done here on a simple section that says, okay, we know it holds up to these characteristics? Is it more than that? Or really, how easy is this, and can it be essentially brought to the US more rapidly?
Yeah, absolutely. Great question. I can maybe start, and then Lily, you can fill in the gaps. So the answer is, of course, it depends on the steel. But I what I will say is that while there is existing protocol that's fully published in outside of the US in about 4 different countries, there actually is a design guide, a design protocol for structural engineers currently in progress. So hopefully it'll come out in the next 2 years by the American Institute of Steel Construction. So it's an active protocol that is being written. What I will say is that we have this wonderful field of historic building preservation that has all of these kind of diagnostic guidelines for tests that need to be done on historic steel structures already, meaning that the protocol already exists. It's just not nicely packaged for structural engineers. Meaning that it's not what this work of this new design guide is doing is saying, like, if you have steel of this grade from this time period, here's what you need to do. If you have steel that's used in this capacity, here's what you need to do. And so what I will say is, yeah, for newer steel, it's a much more, if it's steel from the last 20 years, it's much more straightforward. If it's steel pre-1970, there's more intense tests. And yeah, it depends on what type of loading the structure is under, et cetera. But what I will say is that it's not a structural question really, or not a structural research question still, because it's been largely solved. If that makes sense. Lily, did I miss anything?
Yeah, I think largely it's I guess assessing for deformations, which largely, like, the capacity can be seen without destructive testing, just in the field. Correct me if I'm wrong, Juliana, but it depends slightly on the prior use. Steel from bridges can be challenging, but largely steel from buildings has not really been used to its full capacity, even in buildings that have reached their full lifetime. And so, yeah, there are protocols already in place.
Yeah, and
Go.
sorry. No, I was just going to say that typically for structural engineers, there are diagnostics people that often work for various companies that are responsible for doing this type of certification work. But yeah, there's definitely a lot of existing tests for how to understand the strength and capacity. But yeah, there's definitely like path of least resistance, easiest case studies to start with, which is what we would say gravity systems typically under typical gravity loading. But then also Lily has uncovered all this wonderful reuse that happens on bridges, which are obviously not the same type of structural loading scenario. So I think that the protocol exists for how to reuse from the structural standpoint.
It was something. I'll open up to the group if anyone has any questions. I might have one or two more, but like I said, if anyone wants to ask any questions to the presenters, now's the time.
I'll go ahead here. So great information. Can't wait to actually look through all the links, and a wonderful collection of resources for that. So I'm LeMessurier, so I'm very interested in this stuff. One thing, we were digging into this, I was helping a grad student who was doing a project on designing for deconstruction. So we're digging into it, and it was interesting talking. Michael, you put me in touch with Dan, I think it was, for deconstruction. And from what I could glean, there used to be a much more robust market for deconstruction, salvage steel. And then with the advent of all the steel plants switching over to EAF, all of a sudden it's the scrap metal that has a higher premium than the salvage. Do you find that, was that something that you guys had found, that in a unfortunate way that kind of undermines the reuse? And do you have any suggestions or thoughts on how the markets could shift for helping support the circularity?
Yeah, I can speak to this one, then Juliana, you can jump in. It's definitely, that's come up a lot in the bridge context. there is a certain offset in for example, in the Ohio case that the state pays the contractors a little bit extra on the demolition because they can't recover the material from scrap. But
Oh,
I
interesting.
think sorry.
Interesting. Sorry.
Yeah, it's I think it'll with a more robust centralized marketplace, the higher cost of reused steel right now has largely to do with transport because we don't have those supply chains and networks. And once that's established, I think the price between the two will really close.
Yeah. Oh, interesting.
I guess the only other thing I would add, this is this Dan Costello who told you that?
No one told me that. It was it was Dan that we were talking
About the history of the market?
Yeah, he's like, oh yeah, we used to do it, but now we get more money to just send it for scrap.
Yeah, that makes sense. He's awesome. He's actually donating a bunch of
Oh,
used
nice.
steel for a project that we're building in Cambridge, which has opportunity to be involved with. So sorry, I have lots of opportunities for collaboration. So
Good.
whenever I get to talk to practitioners, I always have to advertise, because that's the fun part of our research too, is that we actually can collaborate
Well, we
with
should,
industry.
yeah.
But what I'll say is that I work a lot. So today I showed you my kind of the carbon reduction research, but I also do a lot of work on material flows and material flows of end of life steel. And one thing that like keeps me up at night is like, oh my God, there's this amazing recycled scrap supply chain. What if we displace scrap that could enter this recycling supply chain and disrupt that system? So I've to wrap my mind around it, I've spoken with lots of steel recyclers, and the reaction, I always get the exact same reaction, which is that the amount that we would be able to institute, amount of reused steel that we'd be able to institute, would in no way even make a dent in the amount of steel that's recycled.
Yeah.
So
I think because a lot of the steel's not from buildings, right? It's like car scrap
exactly.
and stuff.
And so using like on your project, on your new steel project, having 30% of the steel being reused steel would in no way displace or disrupt have any influence on the steel supply chain, the recycled steel supply chain. So
It's interesting. I'm getting deja vu from on the timber side, looking at mass timber. There's a lot of concern of like, oh no, am I going to decimate forests? And all the forestry people are like, no, we've got the quantities for you. There's no problem. It won't impact whatsoever.
Cool. Yeah.
You know, again, with sustainable practices, of course, forestry management practices. So, well, that's good to hear. Nice.
Great question.
Well, we should touch base too, because I am interested in like hearing more about the Cambridge project that you're
Yeah,
looking at
definitely.
too. Yeah.
I'll follow up with you.
I saw you said you interviewed with suppliers and contractors, and I'm curious if you could say more about what you learned from those interviews.
Yeah. I think I'm consistently surprised by how much steel there is just out there. I think we've said it a couple of times in this presentation, but there is just so much waiting to be used, just and so many random places across the country. I think there are also some interesting stories. I learned that a lot of demolition resellers and demolition contractors got their start in deconstructing oil rigs and reselling that steel. And so there are some interesting kind of historical tidbits, but again, it's I guess the quantity and also the word of mouth. And if I can come back to the Ohio case study, like speaking to contractors there, there's a very dynamic exchange always between municipal engineers and surrounding contractors. Well, they'll call each other and say, hey, I just finished this like box culvert bridge. I have some extra. Do you want them? And so the social networks that facilitate that kind of reuse, yes, it's kind of on the smaller scale, but that was a really cool finding.
Have you heard, following up on Olivia's question, I feel like I've heard that some of the larger GC like contractors are starting to see about having land, warehouses or something to be able to, as they're demolishing, be able to store? You haven't come across that?
No, if you have any resources
I'm
or
trying to-
contacts, I'd love to follow up.
I'm at that age where my memory's starting to go, and I'm like, I know I've heard it, but did I just imagine? I can't quite source
And
it.
warehouses and industrial typologies are really awesome use cases or examples where there'd probably be like a very, Michael, to your point, like that is a very simple structural loading question. And so this things that are like very have similar typologies that are often replicated, these things, there's lots of potential. So yeah, please pass on anything you know. The last thing I'll say, because I also have, Olivia, to your question, have spoken with lots of contractors and mainly steel fabricators, and I always feel, and demo contractors, and I always feel that like I learn way more in like a 40-minute conversation with a demo contractor or fabricator than I do doing like a week of literature review. And it's because this, for example, this study that I presented today, we got all of our process data mainly from demo contractors and this boulder deconstruction project. So like what techniques were used when they disassemble these elements, etc. So that's all like very much influenced by these conversations. And then yeah, just to echo, I think Lili hit the nail on the head with really understanding like material narratives and where pockets of material exist. So I didn't know this surplus steel is like common basically at every fabricator until I was at fabrication facilities, for example.
Yeah, to add on to Suzanne's point, there is, I mean, we'll look more quickly broadly at just all reuse of materials. There's the storage question is always going to be a huge part of it all. And to have a third party that has storage would be great, but really, does that exist right now? And if it does exist, does that exist at a cost that makes sense? So a lot of times, some of the biggest of the GCs, I would say, across the country in this region, have storage space that they're typically using for their own kind of field teams. What does it look like between GCs and even the Dan Costello's of Costello Dismantling, where it's, hey, we have all this equipment, we're doing the nitty gritty here. We don't want to use a third party, and it makes the most amount of carbon and cost sense to, in between projects, do this, and we can just store it in our own warehousing space. That is a concept, I think, in the last year or two that has really started to take off. Once again, you need to be at a certain critical size or critical mass to be able to say, I have enough space to capture all this. A smaller mid-sized GC or contractor probably won't have that space. But if you do have that space and you are large enough, that's something. Or if you can work with a government entity that can either lease at a discount or kind of use within kind of the decarbonization lens and policy to use something like that for space. That is something that is also being looked into. But a really, if that can be unlocked, I think a lot of the industry thinks, hey, if we can have this cheap storage space, that will facilitate a lot of this alongside a marketplace where you can actually see and eventually design towards.
Yeah, and if you don't mind, I love chatting about these because like one of the things we were looking at a project where we were demolishing a building on site, and we're like, oh, we could salvage some of the steel, and we'd actually figured out where we could place some of the steel on the new project, and it just got killed by the contractor because there's just logistically, where do you store that steel for like a year or 2 years kind of situation, and they're just like, yeah, it doesn't work. I don't know if you've talked with KLNA structural engineers out in Denver. They had done the project. And so one of the things I was just talking with Alexis last week and picking her brain of like, how did you, so they did this project where they deconstructed, I think it was a fire station, and then were able to use some of that steel in the new hospital. And one of the things that I took away was it really helped being the same client. So I really like that you guys pointed that out, where the client could, and they also could just leave it on the property and then be able to use it on the new project. And I think there's still some surplus steel that they're just pulling and just using it for other projects as well too. So I did notice there was a DEP. So I would on the call. So I do feel like the government agencies actually are great, like lead by example of, hey, let's try to figure out how can we do this, because they have that portfolio of projects, and then that starts jump-starting the infrastructure and the familiarity. But wonderful.
Totally. I also just want to jump in on that quickly and Boulder has been really aggressive in pushing reuse targets and also embodied carbon quantification for building materials. And so it was the city that really enabled that project.
Jacob.
I was gonna ask how the surplus steel that's expiring on fabricators' lots fits into these flows, because obviously it doesn't need to be deconstructed. It's already deconstructed. Does it need to go through the same testing processes that reused steel would need to if it were coming out of a building? Or it seems like it's right there to go back into the supply chain. How do we make that happen more easily?
Yeah, great question. So it depends on how old the steel is, how long it's been in the yard. So the steel in the image that I showed you had been there for 10 years, which is why they needed to recertify it, and they couldn't, because at that time there was not protocol. But steel that has, like, typically in fabricator yards for 1 to 2 years will often get reused or be used by the fabricator when they have a project that fits that steel. That's why they call it like non-dedicated inventory. But as I said, a lot of it goes unused. And the thing that could help with that is that I always tell every structural engineer typically to ask their fabricators what type of non-dedicated inventory they have if they have a wide range of surplus materials. So that's one option. That's just like kind of the easiest way to integrate on a project, because engineer would never typically never ask a fabricator that, or even know that it exists. So part of it is just telling. That's why we always include it in our presentations, because when we're in front of structural engineers, we're like, do you know that this exists? You should ask if anything works for that project. So that's kind of my immediate answer. Yeah, Lili and I are actually working on a project this summer that is a survey project where we're asking every fabricator to detail what type of non-dedicated inventory they have. And we'll hopefully publish that in like Structure Mag or an industry facing publication to kind of promote that this exists. But I'm curious to hear everyone on the call's thoughts, and yeah, for sure about that.
Christine.
Hey, so a question and an apology. I came in late, but this is so interesting. So I wanted to ask you about something. I was thinking about all this and I was thinking we need to have this conversation with my team. And immediately the question popped up in my mind. I was like, they're going to ask me. So I'm sorry, basically, if you mentioned this, they're going to ask me, do structural engineers go bananas when you suggest this? Like, because it needs to be proved somehow, structurally speaking. And do same thing. Contractors go bananas because it's like, how are we gonna work it out? Where's it gonna come? It's gonna come all in the time that we need it, actually. Like, how is in your experience like with both of these parts working on?
Yeah, I think you're highlighting two key concerns there. One is the certification and the confidence, and two is the timeline. And those are the key challenges. And in terms of confidence, since there is no official certification, it does really come down to the engineers and architects, but there are a number of precedent reuse case studies for which specifications were written. And we were talking earlier, there are established testing protocols for salvage steel. And on the timeline side, the reliability of when that salvage material can be accessed is a big challenge. And the thing that keeps coming up in case studies, it sounds amorphous, is just involve everyone earlier, get the contractor on board, let them know it's going to be a reuse project super early in the process. But yeah, Juliana, if there's anything I missed.
The only thing is that so my background is in engineering. Engineers typically love adding constraints because then it makes for an interesting problem to solve. So I have actually found most structural engineers to be pretty enthusiastic about working on it as like an intellectual exercise and just like to see if it can be done. Of course, that there's a big range, and that's actually to say something, because normally engineers' first concern are we like to find points of failure. And so I've sat in a lot of calls where, it's always a good sign when engineers want to poke holes in an issue, because then they're interested. But yeah, so I would say most engineers I've talked to who have worked on projects like Alexis, that Suzanne mentioned, have been pretty enthusiastic about trying to make it happen. And there's a lot of additional things that come up that make it a challenging problem. So that's on one end. I think Michael could probably speak way more to the contractor side. In my experience, it's about who's paying for it. Yeah, it's not necessarily about capability, but yeah, it's additional services, and so it's additional cost. But I don't know, Michael, if you have any other insight or thoughts.
Yeah, I would just say, coming from the contractor's point of view, it's if something is, it's all part of the procurement process. So if we know exactly where to procure it, then it's just a cost and timing, as was mentioned before. And if it's available and it's just, hey, it's in the specs, it's in the drawings, and this is what we need to do, it'll get done for the most part. I think the problem is oftentimes there's 11th hour sustainability ads, or if we're brought on a week before the bids go out before this and the timeline is really crunched. I think that is what oftentimes a lot of contractors turns up the heat on risk aversion. And hey, if I don't have time to really wrap my head around this and my estimating team and my operations team, then our industry gets a little frantic and scared, I would say. But with enough runtime, I cannot stress enough the early, whether it's in a dedicated pre-construction or whether there's a bit of room to run in the just typical process of onboarding a contractor, the more time, the better. And the more time to look at something that is, no, this is exactly where you're looking to get it from. This is the exact contact who has all this knowledge, and hey, we need 15 members and here are where the members are going to be. I think that makes it easy enough to where you can really make this process a success on the project and then repeatable, because it's a good taste in your mouth after there is a success like this.
From architect to engineer, if we proposed, hey, let's actually do this with structural steel, would you think, oh my gosh, this totally needs to be an ad service, like this is not how we design, or the, intellectual challenge of it, like, yeah, this is just the project and how we'll figure it out?
It's really up to the engineer and also up to the project. I think, yeah, because it's so emerging, I think a lot of people are willing to do it because it's will be a precedent project. But I think it really depends. Yeah.
And again, I think public incentives come into this. There's now for the Greater London Authorities has a stipulation of a minimum amount of reuse in a lot of the buildings that are of a certain size, and so that kind of just incentive really drives bigger uptake.
Any more questions? I have one more, but I want to open up to the group before, with a couple minutes left. The one question I would have, and once again, I'm not a structural engineer and haven't researched this. I imagine there's different kind of grades of steel and different kind of components of what's going into the steel itself. The steel is probably a blanket category of several different kind of very specific items for, I need really high strength steel for this or that. In your research, did you find that certain kind of types of steel would be better for reuse, better for kind of putting into new projects? With the bridge project, it almost kind of seems like downcycling it a bit. But was that part of the research at all?
So there's a robust kind of history of different steel capacities in different decades based on various building codes that can be referenced, and that's how a lot of these project-specific specifications are written based on when the prior building was constructed. But overall, capacities remained pretty consistent, as kind of the Met Warehouse example shows. Steel in buildings is kind of as it was 100 years ago, which is pretty amazing.
Actually, just a quick question to build on that. Did you find any issues of like the different coatings over time and how that affects the steel?
Yes.
Options.
There's definitely an added cost in fabrication after, if you have certain kinds of coatings. It lead obviously adds, but there's a surprisingly that's not talking to contractors and fabricators. That's less of an issue than you would expect, at least in the bridges case. And so then there are a lot of ways to post process.
So I just shared in the chat one of our colleagues' paper that details like the history of steel specifications over time and how that influences capacity. But again, I think Lili covered it in terms of that capacity of A36 steel, which is often the steel that exists in our buildings back then is the same as now. And there are some changes that happened before all steel was standardized in 1970. So pre-1970 steel often has a different carbon content, and so then can have certain implications on weldability, really exclusively, not necessarily on structural capacity, but just on weldability. And so there are metallurgic tests and protocols for how to assess all of these things that will be included in the protocol, the structural engineering protocols.
I was looking now as we were talking that the SCI has this sort of protocol to reuse steel. I don't know if it's something that you have in the research, like embedded or so. So if it's something that could be more mainstream somehow to make it faster.
Yeah,
Yeah.
it's a really great resource.
It is. It's really awesome. I think Lili has that in the slide deck she'll send out.
Okay.
I'll share it. Yeah.
Awesome. Well, with that, there's only a few minutes left. I want to thank both Lili and Juliana for coming on today. This structural steel reuse has been something that has been talked, I think, about a lot in the past couple of years as we're looking to grow the reuse ecosystem and kind of move more fully towards circularity. So thank you so much for spending time today and really getting into this topic that I think a lot of us have been thinking about. So thank you.
Thanks
you.
for having us.
And then I would ask as well, if you're comfortable with it, please share. You can just share it with me and Olivia, and we'll look to spread out to the group next week when we send out the meeting recap. But any of the resources we'd love to have so we can share with the group.
And again,
Awesome.
we're looking for collaborators, so please reach out.
Yeah,
Sure, yeah.
feel free to send us the opportunities whenever you have them, and we can publicize it to this group of reuse supporters. And we have a
Yeah.
wider network. So
And
Yeah,
I'm gonna
awesome.
reach out specifically because my team wants to know more. So you're gonna get an email from me.
Awesome. Great.
Yeah.
Yeah, thank you all so much. I am realizing that a lot of us are on various committees or on other things together, so it's lovely to see everybody. And yeah, please reach out also just with questions. You don't need to reach out necessarily with a collaboration offer too. So yeah, cool. Thank you all so much.
Thanks, everyone.
Awesome. And
Thank
just in
you.
closing,
Thank you.
before we close up the meeting, I want to share one more item for, we mentioned this in the beginning, but the Mass DEP does have their Waste Reduction Innovation Grant out. So this is two different types of grants. One, the smaller scale for innovation on projects, research for anywhere from $50,000 to $100,000. And then the second type is looking for capital investments, anywhere from $500,000 to $2 million. So applications opened up, I think, about a couple days ago on the 15th and run till July 15th. I don't know if we still have Mass DEP. I want to quickly talk about that, but quite an opportunity to say the least.
I can just hop on and say if folks are interested in that grant, definitely take a look at the guidelines that Michael just put into the chat. And then also, if you have questions, you can reach out to Joanne Lai from our team. We're entering like a formal question and answer period once applications are live, like this one. And then I also threw in the micro grant, which is a very small grant. It's $3,000 to $10,000, but deconstruction is something we're looking for. It's one of the types of projects that you could apply for. So whether it's like paying for a contractor to help with the process, etc. But anyway, where I was going with that is that now that they're open, there's a formal question and answer period. So just make sure if folks have questions about them, send them in writing. For the microgrant, send them to myself. I'll put my email in the chat. And then Joanne's email is on the Waste Innovation Grant webpage.
Right. And the only thing I would add, I know folks need to leave, is that for the Innovations Grant, which is not the group that Leah and I work in. It's in the commercial branch of what we do at DEP, but they really are looking for game-changing ideas. They want game-changing proposals. And so this is really a novelty to have a grant of this size. They know that we really need to do more and something bigger to really move the needle on reducing waste here. So just want to make the plug for that. So, you know, be bold. Don't be afraid to be bold.
Kathy and Leah, we really appreciate that. We'll probably follow up in the next couple of meetings as this period is open. But it is 2 o'clock. It is quitting time. So want to thank everyone, including our presenters once again for coming today. As usual, we will end this recording, put it on YouTube and include it along with some meeting notes and links. Like I said, Lili and Juliana, if you want to send them over to us, we'll include those as well and your contact information. So thank you everyone for coming today and have a good, hopefully good weather as well, long weekend. And we'll see you next month.
Thanks, everyone.
Thank you, everyone.
Enjoy.
Thank you.